Today's seminar is going to focus on scientific notation, and what we will be looking at specifically is operations, so addition, subtraction, multiplication using scientific notation, and changing from standard form to scientific notation and scientific notation to standard form. The two goals that we will have for this lesson are I can apply operations to numbers written in scientific notation, and I can convert between standard and scientific notation. Those will be your two goals. So at this point, I would pause the video and write the title of the lesson in and the goals for our lesson. For this lesson, you will need two foldables. You will need your laws of exponents foldable that we had, and we'll be working with the scientific notation portion in the bottom. And you will also need this one here, which talks about how to apply the different operations to numbers written in scientific notation. The first one that we'll be starting with is the laws of exponents one that we worked with last week. So we'll start there. And we'll first focus on converting between scientific notation to standard form and standard form to scientific notation. So in our booklet here, we have rules for each of these. So let's start with standard form to scientific notation. So what it says is, if a number is greater than 1, the exponent will be positive when we're switching from standard form to scientific notation. And if a number is less than 1, the exponent will be negative. And we'll do a few examples here in a little bit. And like always, I'll do them on a different sheet of paper so that they're bigger and easier to see. But you can definitely write these examples in the space provided to you here. And secondly, we're going to look at scientific notation to standard form. And things that we follow with this are, if the exponent is positive, we'll always move the decimal to the right based on what the power is. And that tells us how many we need to move. And the same thing, if the exponent is negative, we'll move the decimal to the left, however many the exponent tells us to. So let's go ahead and do a few examples, and we'll start with standard form to scientific notation. Okay, so referring to our booklet then here, we have if a number is greater than 1, the exponent will be positive, and if the number is less than 1, it will be negative. Well, this number here is less than 1, so we know that our exponent will be negative at the end. And the first thing that we need to do in order to convert this is move our decimal place until we have a number to the left of the decimal point that is a number between 1 and 9. With scientific notation, the number to the left of the decimal point needs to be a number between 1 and 9. If it's 0 or less than 1, we have to move the decimal, and if it's bigger than 9, the decimal still needs to be moved. So that's something to keep in mind as we work through scientific notation today. So if I want a number to be between 1 and 9 in front of the decimal or to the left of it, I have to figure out which way I need to move. Well, if I move to the left here, I'm going to keep adding zeros, and that's just going to keep getting smaller. We don't want that when we're writing in scientific notation. So I want to move to the right until I get a number in front of the decimal that is between 1 and 9. So if I were to move the decimal to here, I would have 3 in the front, or to the left, and that would tell me that I've moved enough and I don't need to move any further. So if I were to rewrite this, then I would have 3.481 times 10, and since the power that we have here needs to be how many spaces we move. Well, we moved 2, but once again, like I said in our rule book, if the number is less than 1, the exponent is negative. So instead of a 2, we would have a negative 2 here. And that's how we would convert that first one. Now let's take a peek at our second one. The number is 159,830. Now this is a number that is greater than 1, so our exponent will be positive. Now with a whole number like this, the decimal place would be all the way at the end or all the way to the right hand side. And we're going to need to move this in so that we have a number that's between 1 and 9. So let's go ahead and do that. And I'm going to have to move to the left in order to do so. So I need to move 1, 2, 3, 4, 5 spaces. If I move 5 spaces, the number to the left of the decimal is a 1. That meets that requirement of having a number between 1 and 9 to the left of the decimal. So I would rewrite this number, 1.59830 times 10, and we move the decimal place 1, 2, 3, 4, 5 spaces. So to the 5th power. Now, as we'll learn in a second how to change from scientific to standard, if I were to double check this, it would come out to this number. So that's how we go from standard form to scientific notation. So let's look at scientific notation to standard form then. And remember, our rules are, if the exponent is positive, we want to move the decimal to the right, and if the exponent is negative, we want to move it to the left, however many the exponent tells us to. So if we look at this first example, I'm going to write my 1.45 down here. I have a positive exponent, so that means I need to move to the right 4 spaces. So 1, 2, 3, 4. Now you might be wondering, what do I do with these blank spaces here? Well, those are place values, and we don't have a specific number that goes there right now, so we're going to fill those in with zeros. So after converting this, I should end up with 14,500. And if I think about that, 10 to the 4th power is 10,000. If I'd multiply 1.45 by 10,000, I would get 14,500. Now similarly, with the second problem, we need to move the decimal, but in this case we need to move it to the left because the exponent is negative. If the exponent is negative, it's signifying that we have a small number or a number smaller than 1. So let's go ahead and write this down, 5.82599. And since my exponent is negative, I need to move to the left 3 times. So 1, 2, 3. And once again, like in this problem where we filled in with the zeros, we would fill in with zeros here, which would make my final number 0.00582.599. It's a number that's smaller than 1. So this makes sense. Since this is a negative exponent, we should have a number smaller than 1. So those are your conversions between standard to scientific and scientific to standard. Please, when you're doing these problems, refer to your notes here as they will be very helpful to you. Remember, your examples can be written in this space here. So let's switch gears here a little bit, and let's move into applying operations to numbers written in scientific notation. And first we'll start with addition and subtraction. But before we get into that, I'm just going to show you quickly how you should set up your foldable here. So you'll end up with a full sheet of paper that looks like this. This on one side and this on the other. What you'll need to do is fold these edges in so that your notes are on the inside, and then cut along this dotted line here, just halfway though, so that you have flaps for each one. And then as always, this should be put into your notebook when you're finished. So let's start with adding and subtracting in scientific notation. They're pretty similar other than doing addition and subtraction after we've gone through the steps. So with addition and subtraction, there's a big rule that we need to remember that isn't necessarily applied to multiplying and dividing. Well, it actually isn't applied, so this is something we need to make sure that we're doing when we're working with adding and subtracting in scientific notation. First here, make sure that the exponents of both numbers are the same, and I'll show you how to do that in a second. To add decimals, and don't forget when you're adding decimals, you need to line up the decimal points and the exponents will stay the same. And then once again, like I was talking about with converting, we need to make sure you have a one-digit non-zero number in front of the decimal. So numbers 1 through 9. And similarly, subtraction is over here. The only difference is that instead of adding numbers in step 2, we would be subtracting numbers. And I'll get to this point in the middle in a second. This applies to addition and subtraction. And if you need to move the decimal if it doesn't meet that rule of having a one-digit non-zero number in front of the decimal. So to change the exponent, count how many times you need to move the decimal. If you move the decimal forward, add that number to the exponents. And if you move the decimal back, subtract that number from the exponent. How I like to remember this is forward, you add, so forward, kind of goofy, but it works. And if you're moving back, you subtract. That kind of rhymes. It's a good way to remember that. So like I said, the rules are very similar here for addition and subtraction. So let's go ahead and do 2 examples. We'll do one addition and one subtraction. You can write your examples in these spaces provided here. However, I will do them on a separate sheet of paper so it's bigger and you can see it. So we'll start with an addition problem and we'll refer to this as we work through them. So addition and subtraction with scientific notation. So we'll go ahead and start with this. So the first thing that we need to do is make sure the exponents of our numbers are the same. Well, right now they're not. If they happen to be the same, like let's say they were both 6, we could add these 2 numbers right away, this 9.7 and 5.4, and then your answer would just be to the 6th power, times 10 to the 6th power. Similarly, if both of them were 4, we could add these. But if they're not the same, we have to do something before we add these numbers. So, what you can do, you have to figure out which one you want to be the exponent. So if we want 4, we'd have to add 2 to this side. And if we wanted to make this a 4, we'd have to subtract 2 on this side. In this problem, we'll subtract. So I'm going to rewrite these real quick. 9.7 times 10 to the 6 minus 2. So that would be to the 4th. And then plus, this one's going to stay the same because we didn't change it, times 10 to the 4th power. Well, here's where this rule is going to come in that I had mentioned before. To change an exponent, count how many times you need to move the decimal. If you move the decimal forward, add that number to the exponents. If you move the decimal back, subtract that from the exponents. Well, in this case, I'm subtracting, so I need to move this decimal back 2 spaces before I can add these numbers together. So if I have 9.7 and I want to move back 2 spaces, remember back's going to be to the right, so I'd go 1, 2, and fill in the 0. This number now becomes 970. So over to the right here, I'm going to add 970 to 5.4 because now they have the same exponent, the 4th power. And remember, we need to line up our decimals. So 0 plus 4 is 4. Bring the decimal point down. 0 plus 5 is 5. 7 plus 0 is 7. 9 plus 0 is 9. So right now, I have 975.4 times 10 to the 4th power since we switched it. However, we have a problem here. This number does not have a one-digit non-zero number in front of the decimal place. So we need to move this decimal place forward 2 spaces. Now if I move forward 4 I need to add 2 to this exponent as well. So if we go 1, 2, I have 9.754 times 10 to the 6th. I have to add 2 because I moved the decimal place forward 2 spaces. So let's put 4 plus 2 here. And if we were to move back in order to fix it, we'd have to subtract. Remember, subtract, move back, move forward, add, or forward, like I like to say. So that's an addition problem, where we subtracted in the exponents. In the next one, we're going to add, and we'll see that it works the same. So you just have to decide how you're going to get these exponents to be the same. So let's take a peek down here then. Now let's remember this is subtraction. So once we change whichever one of these numbers to the point where we can add them, then we have to remember to line up the decimals and subtract them. So let's go ahead and add 1 to 7 in this case. So I'll copy down this one, 1.7 times 10 to the 8th minus 7.2 times 10 to the 7 plus 1. Now if I'm adding, I need to move forward the decimal place forward before I can add these two numbers together. So 7.2 would turn into 0.72 or 72 hundredths. This would now allow me to subtract these numbers because the exponents are the same. They're both to the 8th power now. So if I do 1.7 minus 0.72, remember you have to line up your decimals. So can't do 0 minus 2, borrow from the 7, that becomes 6. 10 minus 2 is 8. I can't do 6 minus 7, I need to borrow from the 1, that comes 0. 16 minus 7 is 9. Bring your decimal place down. So currently I have 0.98 times 10 to the 8th power. But this is incomplete because currently right now we have a 0 in front of this decimal point. Well, that's not okay. We need to have a digit between 1 and 9. So that means I need to move this back 1 point. And if I move back, I need to subtract from the exponent. So my final answer would be 9.8 times 10 to the 7th. So like I said, it doesn't matter if you add or subtract in order to get the decimals the same. You just really have to pay attention to which way you need to move the decimal and how many times you need to move it. And then of course lining up your decimals and fixing problems like this where you don't have the correct number in front of the decimal place. Remember, that's a digit between 1 and 9 in front of the decimal or to the left of the decimal point. So this is adding and subtracting with scientific notation. Probably the most challenging of the 4 operations with scientific notation. Multiplying and dividing are a little bit easier and have less steps. So now that we've covered that, let's dive back into our foldable here with our notes and go over what we need to do first. Let's look at multiplying and then we'll look at dividing and we'll do 2 examples. So multiplying with scientific notations. What you need to do first is to multiply the decimals, the decimal numbers. So whatever's out in front, we want to multiply those right away. The next thing we would do is add the exponents, just like we do with the product rule with the laws of exponents. So it's following that same idea. And then last, make sure you have a 1-digit non-zero in front of the decimal. If you don't, you're going to need to move it, and whichever way you move it, you're either going to add or subtract from your exponent, like we talked about before. Over here we have dividing with scientific notation, basically the same thing. So you divide the decimal numbers, or the numbers that are out front. Subtract your exponents. This is like the quotient rule that we covered last week in seminar. And then once again, make sure you have a 1-digit non-zero number in front of the decimal. If you don't, you need to move it left or right and add or subtract accordingly. So those are the notes for that. The two examples we do can be put right here. So let's start on those. So we first have multiplying and dividing. Or I'm sorry, we first have multiplying, not both together, although you could do that. So let's look at this first one here. We have 3.7 times 10 to the 6th, and that's multiplied by 6.2 times 10 to the 4th power. Now to save time, I'm just going to use a calculator to multiply those. 3.7 times 6.2 is, so if I do the 3.7 times 6.2, I get 22.94. So I'm going to write that as my leading number for the time being, times, now remember with multiplication, we add the exponents. It's just like the product rule. So 6 plus 4 is 10. 10 times 10 to the 10th. But are we done? No, we're not. We need to move this decimal place one space forward so that the number to the left of the decimal point is a non-zero one-digit number, so between 1 and 9. We move this forward one. If I move forward, I need to add forward, so I need to add 1 to my exponent. So my final answer would be then 2.294 times 10 to the 11th power. And that's as simple as multiplication is. Multiply the two numbers out front, add the exponents, adjust if necessary. Now sometimes you might be moving your decimal point to the left. It just depends. Then we would subtract from our exponent however many spaces you needed to move. So that's multiplying, and the same steps will apply to any problem that you're doing. So second problem here, this is a division problem. And I think I'm going to rewrite this so that we can kind of see the quotient rule happening. 1.2 times 10 to the 8th divided by 2.4 times 10 to the 3rd. So like our foldable said, if we're looking at step 1, divide the decimal numbers. So we're going to divide 1.2 divided by 2.4. And I'm just going to do that in my calculator quick. I get 0.5. So I'm going to write that to the side. Now the next step is to subtract our exponents. So I'm going to separate these real quick, and this is going to look exactly like the quotient rule that we had. So I have the same base. They're divided. That means subtract the exponents. So this should really give me 10 to the 8 minus 3, or 10 to the 5th power. So currently, I have times 10 to the 5th power. But am I done? No, I'm not done. I currently have a 0 to the left of my decimal point, and that's not going to work. So what we need to do is move this decimal point back one space so that we'd have a 5 in front. And if I move back, I subtract the number of times that I move the decimal. I moved it once, I subtract 1 from the exponents. So the number that I would have out here before the multiplication sign would just be 5. You could put 5.0, but it is just 5. Times 10 to the 5 minus 1, which would be 4. And that's our final answer for that one. Biggest thing really here is to understand this quotient rule of subtracting your exponents when you're dividing, and then dividing these two numbers out in front. And of course, following that rule, if I move back, I subtract the number of times I moved. And if I move forward, I add the number of spaces that I moved. In both cases, it was 1. Could it be more? Absolutely. It just depends on whatever problem it is. So that's a quick overview of multiplication and division. You possibly could see problems where multiplication are both in the same problem. That's not unlikely, but you would just follow the same steps and you would follow order of operations. Multiplication would come before division. So those are a couple examples. Make sure you get those written down here on the sheet and that this foldable gets put into your notebook. So just quickly going back to our goal from today, we looked at scientific notation, we looked at the operations, addition, subtraction, multiplication, and division. We looked at converting from standard form to scientific notation and from scientific notation to standard form. You should be starting to feel comfortable with these goals, hopefully, after watching this video. And as always, if you have any questions, please feel free to ask me.